Hello students, this is Dr. C. Sonia, Assistant Professor in Chemistry, SNS College of Technology. So in the energy resources, now we are going to see about an important energy that is nuclear chain reaction. So we have seen about the nuclear fission reaction, nuclear fusion reaction, and what are the advantages and how they are used. And we also seen about the difference between the nuclear fission and the nuclear fusion reactions. So in this video, we are going to see about nuclear chain reaction. So it's important to know about the nuclear chain reaction. So, how it is defined? A fission reaction where the neutrons from the previous step continue to propagate and repeat the reaction is called the nuclear chain reaction. So, this reaction, it's a fission reaction where the reaction continues without stopping, right? So, that is the chain reaction. There's a continuous reaction. So there are certain criteria for the nuclear chain reaction. To continue a nuclear chain reaction, sufficient amount of uranium-235 must be present to capture the neutrons. Otherwise, neutrons will escape from the surface. Okay, so the chain reaction will continue if and only if the neutrons are captured by the presence of uranium-235. Next is the critical mass. So there is a minimum amount of fissionable materials, uranium-235, required to continue the nuclear chain reaction. Example, it's uranium-235 1 to 100 kg. So the mass should be between 1 to 100 kg for a nuclear chain reaction to occur. Next is the supercritical mass. So mass of the fissionable material is more than the critical mass. If the mass is greater than the critical mass, it is known as the supercritical mass. Subcritical mass, when the mass of the fissionable material is less than the critical mass, then it is called the subcritical mass. So mass greater or less than the critical mass will hinder the chain reaction. So we should have the mass exactly at the critical mass. So here in this we are going to see an illustration of a fission chain reaction. Okay. So uranium 235, it is bombarded by the neutron. So due to that, fission reaction is taking place, and uranium, it's split up into two different nuclei, releasing three neutrons. Okay, so these three neutrons, there is release of two or three neutrons in this reaction, and they are released and they go and bombard with a different uranium nucleus. Okay, then they go bombard. When they are bombarded, then each uranium, it is split up into two different atoms, and also it is releasing another, the uranium 236, it's releasing another three neutrons. Similarly, this is one uranium 236, which that is one neutron which comes out and hit the uranium. Okay, so next is the second neutron. This also comes and bombarded with another uranium 235, which again undergoes the fission reaction to give two different nucleus and also release three neutrons in the process. And the third one, it again comes and bombard with the uranium 235, again giving the fission reaction where it is split up into two different nuclei, and also the uranium 236, it releases three neutrons. So we have in this chain, first you have the three, then you have again three with the three neutrons, means these three neutrons, it will go and hit the new uranium 235. Okay, so each one you have at the end last, we have 3 plus 3 plus 3, 9. So each neutron, that is 9 neutrons, will go and hit and another uranium, U 235. Then again the chain will just continue. Those uranium, they will again emit a different a uranium and two different nucleus, and from there you there exhibit or there comes out the neutrons, which will further go on for the reaction. So this fissionable reaction, this chain reaction, is just goes on unless and until the neutron that is coming out of the uranium is being controlled.